Okay, we can start now.
Yes, sir, we can start now, but I think we'll
Some questions you have, some questions which are
yes,
there.
sir.
We'll clarify that first.
Right. We'll start with the questions. I'll just bring it out for your reference. But it's a pretty critical question, I must say. And I do not know who actually raised this question, but the question goes this way. Why astronomer Cassini showed that it was required to subtract 3 degrees from the sun's position and 40 degrees from the moon's position? If sir, could you please explain?
Yeah. So এটা positional astronomy করার সময় হয়তো একটু বেশি ভালো বোঝা যাবে, but even then, point is that when you develop an astronomical model and develop tables, etc., what is the purpose? Purpose is to find out the locations of various astronomical objects, planets, sun, moon, and to study their motion, how they are moving, because that is the primary objective. Now, when anything about position comes, you decide or find out the position, you have to have a reference. And currently, it is the Greenwich is considered as the 0-degree meridian. Everything towards east is the east and up to 180 degrees. Like, for example, Calcutta's longitude will be approximately 80 degrees east, most probably, I'm not sure. So, in those days, the tables are prepared finally with the purpose to find out the positions of the sun and moon. There, I think the whole tables are definitely prepared on the basis of certain observational data. Now, if the observation was made from a particular location, obviously the reference will be that. And so the tables will be suitable for finding the locations from that reference point. But if you consider that since the tables were found in Thailand, so there you will find some errors. And correct that error, you have to shift your reference to 18 degree towards west. That means it comes around, meridian becomes approximately the meridian of Varanasi. That's what Cassini found.
Okay.
And of course, later his idea got supported by discovery of many more tables in India by others at later time. Were far more comprehensive, complete, more accurate, but on similar direction, similar line, similar type. I told the story of Nalamudu, that Ambudri, how we could use and he predict the details of eclipses. And it really surprised them that how they could do it. So that was the reason that, that table, if you use, considering that observational reference point is Thailand, then the errors are, the positions come slightly erroneously.
So it's basically like, if I raise this concern, like I think it's only because of the position in Thailand, or say, for example, if Cassini was somewhere else, then things would have been changed as well.
No. It has nothing to do with Cassini. Cassini told that if you use this table, considering the observational reference point to be located in Thailand, then the results are slightly erroneous. But to completely remove the error to zero, you have to shift the reference to a location which is about 18 degrees west of Thailand. That is about India.
Now, may I go to the next question?
Yeah, please.
This question was with regard to the various aspects which are directly related with astronomy, and one was with regard to equinox, and the other one was with regard to some of the discussions made by the sages in the form of Brahma Muhurto and things like that. So they want a little bit of clarity. One kid wants.
But I think these questions regarding the equinox, etc., I think we have to have a positional astronomy first.
Okay.
And then I think many of the questions they may have, it may not be required. They may understand. So if there is no other question, we start.
Yeah, there's a last question. It's a very simple question. Maybe I can understand it's coming from a very novice student. And like he wants to know the difference between positional astronomy and descriptive astronomy.
Oh, no, descriptive astronomy is not the correct word. It's a descriptive archaeoastronomy.
Okay,
Yeah,
okay.
they are two different terms. Positional astronomy, today I will start positional astronomy and I'll give the definition what exactly positional astronomy means. But descriptive archaeoastronomy, I briefly mentioned that archaeoastronomy is using astronomical data alignments for finding out the antiquity of a particular type of observation, a particular type of. Now, there are two things. One, as I mentioned, that sometimes you can find that major structures which are aligned in a particular astronomical way, but since the astronomical alignment change with time, so these alignments are definitely now, they show certain degree of error. So finding the antiquity by analyzing that error, that type of archaeoastronomy is called physical archaeoastronomy, where you have a physical system, a huge structure, etc. On the other hand, if you only use a description in some text about certain alignments, stellar alignments and such things, and try to find out the antiquity of that observation. That is called descriptive archaeoastronomy, not physical. You don't need any physical system for that one. So that is descriptive archaeoastronomy, not descriptive astronomy. So welcome. Now I think in the last class our primary objective was uh, to impress upon the students that why we are studying a subject like astronomy, of which was 3-4 thousand years back, which was obviously wrong, because they all considered Earth to be stationary and rest of the heaven is rotating about Earth. So definitely the whole thing was based on some wrong, the wrong premise, whereas the reality is different from what. So what is the purpose? Because obviously now we know far more better than anything in the Hellenistic astronomy or ancient Indian astronomy. So what is the purpose? That's what I was explaining, that ancient astronomical description can help us in the unraveling of certain chronological data about ancient past India, where particularly the prehistoric period, where there is no written record in a formal way. So, but that was what I was discussing. But today, I think I'll start with the next important that now, what is positional astronomy, etc., that we'll discuss, and then I think we'll proceed. But one thing I must mention, that I thought that I'll take this opportunity to tell our students what exactly our, or at least to our current understanding, how universe looks, how it is, and its modeling, etc. Because through that we will gradually come to our solar system and ultimately to Sun Earth Moon system. Will contract. So therefore, what we will discuss, which will be based upon what is the reality as far as the current astronomical understanding. That's what I think we will do that. So I think, therefore, I will start with, in a brief way, the presenting that how is our universe, at least to our understanding, and gradually we come to our local system and study that. So, positional astronomy, যার বাংলা হচ্ছে গিয়ে অবস্থানগত জ্যোতির্বিজ্ঞান. Now, another thing I must tell at the very beginning, because if you go to any ancient text, and that's why I'm particularly the students, they will find the word Jyotish, like Vedanga Jyotish, etc. Now, Jyotish normally we currently understand is astrology, isn't it? But in the ancient times, Jyotish was used for both astronomy and astrology. In those days, astrology was considered to be an important subject, as I have mentioned in the previous discussion session. But what they used to differentiate between the two, they used to call uh, Ganit Jyotish, that was in our sense today astronomy, Ganit Jyotish. Or Farid Jyotish is actually what we understand as astrology. But both the things used to be described as a Jyotish. So if you say Vedanga Jyotish, it is not an astrological book, it is 100% astronomical. So this particular point, I think our students should remember that Jyotish in ancient text meant everything, both Jyotirvigyan and astrology. But currently Jyotish is only astrology. So what is positional astronomy? I have mentioned here. It is the subject in which the positions of various heavenly objects are seen and studied. Now, you all know that because of the immense distance of all the heavenly objects, we can't have a perception of depth. So the whole thing appears like a punto kora korai ekta, a hemisphere. And all the heavenly objects are embedded in that, moving in that spherical dome, and which in ancient time used to be called as Khagol. The Kha means sky and Gol means the sphere. So celestial dome used to be called as Khagol in ancient India. And these all the planets, moon, sun, they all appear to be located on this spherical dome, celestial dome. The one thing you must recognize here, which is important, what we can observe in positional astronomy. We can observe only that we can observe is the direction in which a particular object is in, nothing else. We cannot say where it is, its position, etc. Nothing. Only we can say that in a particular direction, a particular object is seen at a particular, nothing else. So the celestial sphere has big stars as the background, because we have to study something, we need a background. Void cannot be a background. So therefore, all the stars, which are called fixed stars, are considered as the background against which the particular object's position can be defined. Now, I think I will also explain here, because it should not be misunderstood. What do you mean by fixed star? Here, I think our students should recognize one fact, that the stars are not fixed, like our sun. It is hurtling through space at a tremendous speed of few hundred kilometers per second. But the distance is so huge that that anything at a very far off place, its movement will look slower and slower and slower as that this object goes to far off position. And when it is at a very large distance, then I think even to notice a small angular separation, it will take thousands of years. So, for all practical purposes, those stars appear to be fixed. Because they are so far, you can easily calculate. I'll tell Saurabh to give a quick calculation that if something is at a nearest star, our Alpha Centauri, which is at 4.5 light years, and if it is moving at a speed of 200 kilometers per second, how many years it will take to see its movement through space by 1 degree? You can do it, and you can show that it will be quite a few thousand years. So, since our human life is limited to only 60, 70, 80 years, or even our whole civilization is hardly a couple of thousand years, during the whole civilization, we have hardly noticed any large-scale movement of these, though they are moving. But anyhow, for in the ancient time, this motion was not possible to observe, and so they used to be considered as fixed stars. That means their location in the sky was fixed. Their relative positions are fixed. So therefore, they could easily be considered as a background for any kind of study of other objects. If it is moving, say sun is moving, you could easily see that it is against that background of fixed stars. Its motion could be easily seen. That we will study in details. Thus, the agglomeration of the fixed stars becomes the frame of reference, which the positions of various objects can be recorded. And the continued observation reveals that a few star-like objects change their position with time against this big backdrop of fixed stars. They noticed, if you are noticing something day after day, night after night, year after year, and even sometimes century after century, and you look into the ancient records, you will notice certain changes. The most important notice, of course, you will see that sun's position in this sky against the background of fixed stars cannot be seen because it is so bright, you cannot see the star. But moon you can see. So you can see that every day if you observe, even from if you go to the roof and just for when the sky is clear for a week, you check the location of the moon with respect to few stars, you will find every day it is changing location. So therefore, they found that certain objects, they look like stars, but they are not fixed. Their position is slowly changing with respect to in the background of the fixed. So they were called as planets. So planet in Greek means wanderer. That means they're wandering, they're moving around. And that's why they were called as planet. And in Indian astronomy, they were called as grahas. I don't know, I'm not a linguist, that how graha, because planet you can easily see what is its origin, because these are moving objects, they're wandering, and that's why they are called planets. Just like mechanical engineering, Kostov and others, they will realize that we look planetary gear. Planet gear means what? Which moves. Other gears are fixed in their location. Now, our universe. First, I think let us see how our universe is, because that is the most important thing. And then we gradually will come to our local system. Now, to begin with, let us have some idea about our universe. As in the case of living entities, the basic element is a cell, কোষ যাকে বলি আর কি. In the case of our universe also, the most important basic units are the island universes, that is the galaxies. And uh, the largest number of galaxies, most frequently types of galaxies are the spiral galaxies. I'll come to that. What is that? As cells also have a very complex inner structure, the galaxies also are very complex and are huge systems that I will describe. There are a few types of galaxies, but the most abundant is the spiral galaxy. Like our own Milky Way galaxy, which is our island universe, is a typical spiral galaxy. How a spiral galaxy looks can be easily understood from a view of our nearest neighbor, another spiral galaxy, the Andromeda galaxy. So these are the types of galaxies you can see. Now you see that they look like our satellite pictures of low pressure tornado, your cyclones. Actually, all heavenly objects in the universe has a peculiar thing that everything rotates. Angular momentum has. This is a very serious point, and it's a very important philosophical point for all scientists. Remember that in the universe, angular momentum plays an extremely important role. I cannot go into the details now. Now, here I am showing the different types of galaxies. But what I said, the spiral galaxy, this one, just front view, the spiral galaxies are most abundant. Almost 90, more than 90% of galaxies are actually spiral, not more. Then there are some very few irregular galaxies, no definite shape. There's some barred spiral. Now, spiral means automatically it comes to your mind that it must be rotating. You can also understand the direction of rotation. For example, this one must be rotating, as you can easily perceive. It is rotating like this. Similarly, here also it is rotating like this, but the shape is different. Why the shapes are different? That's a very astrophysical question. We will not go into that. So therefore, the most abundant types of units which constitute our universe is a spiral galaxy. And our own Milky Way galaxy is a very typical spiral galaxy, just like our neighbor Andromeda galaxy. This is how a spiral galaxy actually looks. The other one also is a front view. This is a slightly inclined view. This is Andromeda galaxy. It's a typical spiral galaxy and our neighbor. It is 2 million light years away. And surprisingly, it is approaching our galaxy, which is, of course, a special case. We need not bother too much. And it has certain local objects, like these are called elliptic galaxies. These are also pretty big system. Now, can you imagine how many stars are there in each spiral galaxy, typical spiral galaxy? Can you imagine the numbers? Star means sun. How many suns they have? You'll be amazed. Andromeda galaxy also is approaching Milky Way galaxy, which is this Milky Way galaxy. Our own galaxy looks like a disk or a flat plane because we are at one of the edge. So when you see something towards the center, we are almost at the outer edge. So the whole galaxy looks like a flat plane. That is the galactic, central plane. Anyhow, this is so I think, and after 4.75 billion years from now, it will fill a substantial part of our sky, like with our Milky Way, and this will be our view of the sky 4.75 billion years from now. If Subroto takes his telescope, he will find that yes, this is the look of the sky, quite threatening, you can see. Anyhow, now it is unimaginably vast. As I mentioned, that each or other typical spiral galaxy contains 10 raised to 12 to 13 stars or suns. How many are 10 raised to 12 means what? 10 raised to 9 is a billion. 10 raised to 12 is a trillion. So 10, about 1 to 10 trillion suns are there in each galaxy. Like our Milky Way galaxy also has about 10 to 100 trillion suns. কোটিতে কত হবে সেটা বার করে ফেলো। 10 raised to 7 is a কোটি. So it will be almost
1 lakh
10 lakh
crore.
কোটি, 1 lakh কোটি, 1 লক্ষ। So like Indian budget, কয় লক্ষ কোটিতে হয় যদি আমাদের পকেটে বুঝেছি। So I think each galaxy contains such a huge number of suns, and each star is a sun. It has its own solar system with some habitable planets may be there or may not be there. So therefore, that if we consider our solar system as our world, then each galaxy, spiral galaxy, typical galaxy, has about 1 lakh crore such local world. So, as I mentioned, that our universe is unimaginably vast, if not infinite, both in space and in time. It is still not decided whether our universe is finite in space and time. What is in time? That means it never started. That means it is. যেটা আমাদের রবীন্দ্রনাথের ভাষায় খুব বলা আছে, আই লাইক দ্যাট লাইন। একটা গান আছে মহাবিশ্বে মহাকাশে, তাতে দেখবেন একটা লাইন আছে, অনন্ত এ দেশ ও কালে, অনন্ত এ দীপ্তলোকে। দীপ্তলোক মানে এক একটা গ্যালাক্সি। So according to Tagore, the number of such it is অগণ, and অনন্ত এ দেশ ও কালে, that space time is infinite. It is a wonderful description of our universe. So I think current trend of astronomy is that to believe that it is finite started 14 billion years ago at a Big Bang, and its size also, of course, is 14 billion light years away and so. But now, the James Webb Space Telescope, which has been recently placed in its location, other side of the moon, that is able to see far more distant objects than our Hubble telescope. So it's and it is seeing. I will show you about. And before that, about 30 years ago, Princeton University scientists plotted all the observed galaxies, like 10 million galaxies, then observed, and their locations were computerized and plotted. I'll show you in detail how the plot looks. It's not 10 million, 1 million galaxies, sorry, 10 lakh. No particular variation in the basic structure of the observable universe can be noticed, nor has it ever been possible to notify any curvature of the universe. Because if something has to be finite, it has to be spherical, and so there will be a curvature. But that has all tests and experiments have failed to detect any curvature. It is always flat. That means indications are there that it is infinite. All observational tests have confirmed that the universe in the large scale does not possess any curvature and it is flat. This is the computer generated picture of the actual observable universe of 1 billion galaxies. এই যে ফিগারটা দেখছেন, that means each dot, it is not so easy to decide to separate a dot. The whole thing looks like light, but each dot is actually a galaxy, spiral galaxy, containing 1 to 10 lakh crore suns. So this is the, at least till 30 years ago, this was observable. Now you can see far more, but I don't have that plot. So can you realize how vast our universe is? Even whatever you can observe, it is unbelievably large. And fighting about few inches of your land with your neighbor is so ridiculous. Or fighting about that, yes, this is my God and that is your God, that is also absolutely ridiculous. And I personally believe that every student of class 4 should be taught cosmology, at least the descriptive one, to impress upon their mind that how unbelievably vast our অকল্পনীয় মানে এর বিস্তার। সেখানে আমাদের এই ক্ষুদ্রতা জিনিসগুলো নিয়ে মারপিট করা, লোকের মাথা ফাটানো, it is absolutely so ridiculous. So anyhow, you can see this is 30 years back. We have plotted 10 লক্ষ গ্যালাক্সি আছে, তার মানে প্রত্যেকটা ডট এক একটা গ্যালাক্সি, আর প্রত্যেকটা গ্যালাক্সিতে 1 লক্ষ থেকে 10 লক্ষ কোটি সান আছে। কাজেই ইউনিভার্স, আমরা কিন্তু এটা আমরা দেখছেন এটা একটু ফোমিং স্ট্রাকচার আছে, বাট ইফ ইউ টেক some part of this, all parts look more or less similar. So no, there is fundamental difference in their structure of the universe is visible. আর কার্ভেচার নেই, সেটা আগে বলাই হয়েছে। আচ্ছা, 2021 আগে বিগ ব্যাং থিওরি ওয়াজ দি unrefuted model to describe our cosmos. In 2022, NASA started getting images of the deep field survey with startling results. It is now imperative that we have no other option but to abandon the standard Big Bang theory of an expanding universe. জেমস ওয়েব স্পেস টেলিস্কোপটা এরকম, প্রসঙ্গত আমার ছোট ছেলের যে কোম্পানিতে কাজ করে ওরাই এইটা বানিয়েছিল। Then I think it was placed at Lagrangian point 2. This is sun, this is earth. I'll not go into the details of mathematical of Lagrangian points, but it will generate that Lagrangian points are the pure জিনিসটা ঘুরছে তো, because it cannot be stationary, it has to rotate to sun, then moon has to rotate, is anything you put it has to rotate. So the relative positions change, but these Lagrangian points are that, so that the relative position with respect to earth, moon, etc. remains unchanged whenever it is. So this is the place. This is the moon, and this is on the other side of the moon. This was placed, which is Lagrangian. এবং এটা আরো বহু বেশি দূর অব্দি দেখতে পারে। Its capacity to observe is far, far more than Hubble telescope. And when it released the first deep field survey image, it was unbelievable. So you can see that this is a deep field image. And remember, notice that all these patches you can see, each patch is nothing but a galaxy. If you see a galaxy from the side, edge-wise, it will look like a straight patch, and otherwise. So there are hundreds and thousands of such patches were seen. Now, how much is this in the sky? আপনি যদি এটা মানে ছোট্ট একটা যদি চিনির দানা, যেটা আর কি ছোট্ট মতো, হয়তো 1 millimeter সাইজ আর কি, to keep that in hands distance from your eye, তাহলে ওই চিনির দানাটা স্কাইয়ের যতটুকু জায়গা দখল করবে, this image is of that part. So it is a small tiny part of the sky, and there this is the image. And most disturbingly to the astronomers, many galaxies were found. They are more than 13 billion years old. ইউনিভার্সটা যদি 13 বিলিয়ন ইয়ারের হয়, তাহলে ওর অবজেক্ট এগুলো ফর্ম করতে তো সময় লাগে, দিস গ্যালাক্সিস। So this has created a very serious problem. Not only that, আমাদের বলা হয় ইউনিভার্সের বাউন্ডারিটা 13.8 বিলিয়ন ইয়ার্স দূরে, লাইট ইয়ার্স, but we are finding objects which are at a 20-25 billion light years. How is it possible? So now it has brought a very serious problem for the cosmology, the standard Big Bang cosmology. And scientists are very busy to explain such things, save their theory. But anyhow, it will take many more years to have some. But this clearly defies the standard Big Bang theory. Everybody now. But anything, it's a dogma. Just like Aristotle's heliocentric, geocentric system, they're all dogmas. To remove a dogma, it is very difficult. The reason is a very large number of people's career depends on the dogma. That means their whole life's work was with the basis of a particular observation or theory. And if you say it is all wrong, then they have nothing left. Everything they have done in their lifetime, they're all gone. So they don't allow that to happen. And all scientists fight tooth and nail for keeping their position rather than pursuing the truth. It is a pursuing of career these days. Now, if you consider this is the length is 1 billion light years, then the universe will look like this. You can see just like a foamy structure, and it is made up of these spiral galaxies. Each spiral galaxy is a small dot in this, and each such dot contains এক থেকে 10 লক্ষ কোটি sun. Now, if you consider, you scale down, it is 100 million light year. Then the actual plot, these are not representative images, they are actual plot. Then the universe start looking like that. There are voids and there are cloudy patches. These clouds are nothing but collection of millions and millions or billions of stars and galaxies. Each point here is a galaxy. Each small dot is a galaxy. If you scale down, this is a 10 million light. Then we are gradually coming to our reality. And you can see these dots, then these clouds disappear and the dots start becoming visible. So this each dot is actually a spiral galaxy. And there are some clusters of galaxies which are called galactic cluster, Virgo cluster. This is another cluster. These are all. So galaxies are found to be also sometimes in a cluster where there are hundreds and thousands or billions of galaxies in that cluster. And there are big voids where there is no galaxy, no spiral galaxy kind. And this is our local group. Local group contains certain objects which I'll show. We let us scale down further. 1 million light year. This is 1 million light year. মানে 10 লক্ষ light year. Now light year is a distance which is which represents the distance traveled by light in 1 year. So for example, light takes 8 minutes to reach sun. So sun is at 8 light minutes away. So how much will be 1 light year? Light travels at a speed of 300,000 kilometers per second. And how much is 1 year? Little more than 10 days to 7 seconds. So 3 into 10 days to 5 into 10 days to 7, 3 into 10 days to 12 kilometers. Approximately 4 kilometers, 4 into 10 days to 12 kilometers per second. But that is the distance. This is 1 light year. So you can see, so therefore the nearest neighbor is about 4 into 4, 16 into 10 days to 12 kilometers away. So this is our local group. And in local group, this is the Milky Way, our universe. And this is the nearest neighbor, Andromeda galaxy, at a distance of 2 million light years. This is our nearest a galaxy very similar to our own Milky Way galaxy. Now, a typical spiral galaxy may contain between a few hundred billion to a trillion stars, and their size may extend up to a disk diameter because they are in the shape of disc. There are discus through করেছো? You are familiar with discus through? Have you seen such a discus? পেটের কাছটা একটু মোটা আর সাইডটা একটু ঠিক হয়ে যায়। So it is spiral galaxies they look exactly like that. এবং তাদের ডায়ামিটারটা হচ্ছে কি about 100,000 লাইট ইয়ার্স, 1,00,000 লাইট ইয়ার। তার মানে একটা গ্যালাক্সির one is to the diametrically other point, it will take about 1,00,000 লাগবে একটা লাইটের। So you just try to imagine the vastness of the whole thing, you know. It is not just words or some numbers, etc. All these huge systems look like minute dots when they are plotted as shown in the previous slides. Our island universe is the Milky Way spiral galaxy, shown in the next slide. It is a typical spiral galaxy measuring 10,000 light years in disk diameter. No, it would be 100,000. And the center it is wrong. I think kindly correct it. It should be 100,000 light years. And its central portion is বললাম পেটের কাছে একটু মোটা হয়, সেখানে thicknessটা 3,000 light years. Now, 1 light year is about 9.46 into 10 raised to 12 kilometer. And this is required. This is the sun and the earth এর মাঝখানে যে distance তাকে বলা হয় astronomical unit, diameter of Earth's orbit. And this is so many kilometers. And 1 light year is 150, তার মানে 1.5 লক্ষ astronomical unit. তার মানে একটা লাইট ইয়ারে আমাদের সান এবং আর্থের এই ডিস্টেন্সটা 1.5 লক্ষ বার রাখা যাবে। Another astronomical distance unit is parsec, which is nothing but a distance, which is যেটাতে এক astronomical unitটা একটা angle subtend করবে, which is 1 arc second, which is approximately 3.26 light. So we will not bother too much about this number. Don't worry about this. Only thing I want to say that when we discuss the universe, our distance indicator is by light. And 1 light year is, as I mentioned, about 10 into 10 raised to 12 কিলোমিটার। তার মানে 10 লক্ষ কোটি কিলোমিটার এক লাইট। এবার আসি আমাদের সোলার সিস্টেম। এটা হচ্ছে আমাদের কেন এখন এইসব বড় বড় যেগুলো করলাম, these are all recent findings. Ancient time কিন্তু they had no idea. Even to find out that the Andromeda galaxy is not in our own Milky Way galaxy, it was only towards the beginning of this century. That is a wonderful story. Of course, we may not have time to discuss all those. Our solar system, which is our important thing. Once one gets some idea about the universe, the next step will be to understand our local system, the solar system. So first we learn about our position in the Milky Way. আমরা কোথায় আছি? আমাদের যে island universe Milky Way galaxy, where are we located? And then some discussion will follow about the origin of typical stars and the evolutionary process through which the solar system evolved. সেটা আমাদের একটু দেখতে হবে, কারণ আমাদের যে সোলার সিস্টেমে যে এলিমেন্ট গুলো আছে, গ্রহগুলো, তাদের কতগুলো বেসিক ভেরি ওয়েল অর্গানাইজড ডাইনামিক ফিচার্স আছে, সেটা বুঝতে গেলে we have to also understand how stars are born. The major components of our solar system and some very basic and general characteristics will be discussed. এইটা হচ্ছে আমাদের মিল্কি ওয়ে স্পাইরাল গ্যালাক্সি। এটা অবশ্য কম্পিউটার জেনারেটেড ইমেজ। তাতে কিন্তু আমাদের কত আছে, যেটা বললাম 10 লক্ষ কোটি সান আছে। আমাদের সানটা হচ্ছে এরকম জায়গাতে, এটা সোলার সিস্টেম। আমরা প্রায় অ্যাপ্রক্সিমেটলি সেন্টার থেকে 30,000 লাইট ইয়ার দূরে আছি, about 30,000 light, 28,000 something. It's a location of science. But solar system, you know, solar system, and so therefore we are having a very insignificant location in our huge island universe, about 30,000 light years away. Almost not exactly in the central plane, but a little bit off, but not very much off. Most of the material is contained in a form of a disk, as you can. So কতগুলো গ্যালাক্সি আমাদের আছে, কতগুলো স্টার, 10 raised to 14 stars, and 10 raised to 14, as I mentioned. এক কোটি কোটি star. Don't think too much about these things. Our solar system is at an insignificant position on one of the outer spiral arms at a distance of about 27,000 light years from the galactic center. The sun orbits around the center of the galaxy at a speed of 828,000 kilometers per hour and takes 23 crore years to make one complete round the center. The orbital plane of the solar system, and also called the ecliptic plane, I'll discuss that. It is very important, this ecliptic plane. It is tilted to the galactic central plane at an angle of about 60.2 degrees, as shown in the next slide. We should remember that with our naked eye, we can see the stars located within only 500 light years. আমাদের যত অ্যাস্ট্রোনমি এনসিয়েন্ট অ্যাস্ট্রোনমাররা করেছেন, they all confined to a very small tiny sphere around sun with a radius of 500 light. ওই যে হলদে ডটটা দেখিয়েছিলাম, এইটা হচ্ছে আমাদের সোলার সিস্টেম। আমাদের অবজারভেবল ইউনিভার্স হচ্ছে এখানে যে স্টার গুলো আছে আমরা সেইগুলো দেখতে পাই। The nearest neighboring star of the sun is Alpha Centauri at a distance of about 40,000 billion kilometers, 4.365 light years. Can you see the whole thing? This is the edge view of our galaxy. মাঝখানটা একটু বালজিং আছে, আর বাকিটা হচ্ছে এটা ডিস্কের মতো। এটা যদি একটা ভিউ নিই এরকম, তাহলে এটা হচ্ছে সেন্ট্রাল গ্যালাকটিক প্লেন, এটা হচ্ছে সেন্টার অফ দি গ্যালাক্সি। আর আমাদের সোলার সিস্টেমটা এরকম, মানে সব প্ল্যানেট গুলো ঘুরছে যে প্লেনটায়, যেটাকে বলি অরবিটাল প্লেন অফ মোস্ট অফ দি অল দি প্ল্যানেটস, দ্যাট ইজ টিল্টেড টু দি ডিস্ক বাই 60.2 ডিগ্রি। এবং এটাকে এই যে এই প্লেনটা কি এই যে সান আছে এখানে, এটা একটা বড় এক্সপ্যান্ডেড ভিউ দেখাচ্ছি। The sun and earth is going around this. Now this plane, which is described by the earth's orbit, is called the plane of the ecliptic. Why we call it plane of the ecliptic? Because whenever moon is on this plane, moon is actually slightly tilted moon. So whenever moon is on this plane, there is a chance of having an eclipse. That's why the plane is called the plane of the ecliptic, which is nothing but the orbital plane of earth around sun. এখন আমরা যেগুলো বলি, আমি পরে একটু আসবো আবার। এখন গ্যালাকটিক সেন্টারটা হচ্ছে গিয়ে এই ডিরেকশনে, আমাদের এখান থেকে দেখলে আমাদের প্লেনটা এরকম। আর কিছু নক্ষত্র যেটা আছে সেটা আমি পরে আসবো, which are shown in the various directions. There are about 27 of them. I will discuss that later. কাজেই আমরা যখন পৃথিবীর থেকে আমাদের প্লেনটা কিন্তু এরকম ইক্লিপ্টিক প্লেনটা, and you can see that আমাদের গ্যালাকটিক প্লেনটা হচ্ছে এইটা, আর আমাদের অরবিটাল প্লেন ইক্লিপ্টিক প্লেনটা এরকম হবে, কারণ আর্থ অ্যাক্সিস ইজ টিল্টেড। কাজেই মিল্কি ওয়ে as seen from the earth, এটা আমাদের এমনি খালি চোখে দেখতে পাওয়া যায়, আকাশ পরিষ্কার থাকে। And this is nothing but the আমরা গ্যালাক্সিটা দেখছি from one edge, so it looks like this. এই কালো কালোগুলো হচ্ছে গিয়ে ডাস্ট, প্রচুর ডাস্ট থাকে আমাদের, এই ডাস্ট গুলো অবজেক্ট করে রাখে, যে জন্য সেন্টারের অনেক স্টার আমরা দেখতে পাই না। আর আমাদের ইক্লিপ্টিকটা হচ্ছে এইটা, আমরা পরে আমাদের আসবে, ইট উইল বি ভেরি ইম্পর্টেন্ট লাইন ফর আস। এটা হচ্ছে 60। সো ইক্লিপ্টিকটা কি, এগুলো আমরা খুব ডিটেইলে ডিসকাশন করবো, কারণ দি হোল অ্যাস্ট্রোনমি আমরা ডিসকাস করবো, ইট উইল ডিপেন্ড অন দিস বেসিক থিংস। গ্যালাকটিক প্লেনটা আমাদের খুব একটা কাজে এখন লাগবে না, কিন্তু আই জাস্ট ওয়ান্টেড টু শো ইউ ওয়্যার ইউ স্ট্যান্ড অ্যান্ড হাউ ইট লুকস। যে আমি যেটা বললাম যে সান, এগুলো হচ্ছে বিভিন্ন প্ল্যানেট। মোস্ট অফ দি প্ল্যানেটস ইউ ফাইন্ড দে আর কনফাইন্ড টু এ প্লেন, which is very slightly tilted with our ecliptic plane, which is nothing but the orbital plane of the earth. তো বাকি প্ল্যানেট গুলো সব মোটামুটি ওই একই কাছাকাছি প্লেনে করে, এবং the distance of the earth from the sun is defined as 1 astronomical unit. সেটা কত ডিস্টেন্স সেটা বার করে না বলি আমরা 9,30,00,000 মাইল, তাই না? আমি জানি না, আমাদের ছোটবেলায় যা পড়তাম। So I think you can calculate. So this is the sun, this is the Mercury, This is Venus. Then we come Earth, then Mars, asteroid belt, Jupiter, and Uranus, Neptune. But in ancient astronomy, remember one thing: this Uranus and Neptune, they are not known. They are discovered much later in the telescopic astronomy era. So in the ancient astronomy, used to stop at so that also it was discovered much later. So in the very early ages, it was primarily Jupiter and Venus. These are the two most easily observable. And then came Mars, and finally Saturn, Mercury. So these were the things, and along with that, we used to call Moon and Sun two planets because they are also moving around this. So this way, the total number used to be 9, and Rahu and Ketu. These are all fictitious things. In total, there used to be about 9 such objects in the sky moving around the Earth. So that's why we have the call নবগ্রহগুলি না আমরা প্রত্যেকে কিন্তু অ্যাকচুয়ালি ইন আওয়ার এনশিয়েন্ট ইন্ডিয়ান অ্যাস্ট্রোনমি উই নিউ অনলি আপ টু স্যাটার্ন আমি যদি তাদের সাইজগুলো দেখি সান ইজ সো বিগ তার একটা খুব স্মল সাইজের চাঙ্ক একটু যদি দেখি এইটা তাহলে অ্যাকচুয়াল সানটা কমপ্লিট করলে সার্কেলটা কত বড় হবে ইউ ক্যান ইমাজিন সো মার্কারি একটা ডট ভেনাস আর্থ মার্স জুপিটার স্যাটার্ন ইউরেনাস so you can see approximately the relative size of the planets and the sun. Now, before I go further, is there any question up to this point we can take up? If there is any point.
So I think the description and the views and the pictures are so clear that
You do not have any question.
any young kid can understand it very clearly.
Okay, okay then. So then I proceed now to consider the dynamical characteristics, how our solar system objects are moving. Now, I think one very important thing which I don't know, the 99% of the matter of our solar system is actually contained in the sun. Only 0.1% material is contained in the other objects like the planets, etc. Kintu, oh, and also all 9 planets orbit around the sun in the same direction, anti-clockwise viewed above the Earth's north pole. এই যেমন দেখাচ্ছি প্রত্যেকটা গ্রহই কিন্তু একইভাবে ঘুরছে র্যান্ডম কিছু নয় and almost all in approximately the same plane except Pluto, which is inclined by 17 degrees to the plane. And actually, to কাজেই এটা একটা খুব clear cut picture of the system is very well organized. That they are all rotating or orbiting in the same sense, in a orbits which are approximately in the same plane. And also later it will be seen that most of them are also spinning in the same sense. So this structure, very well structured system, leads us to think about the origin, that how the solar system was born. Because you remember that birth of the sun is, in a modern theory, that is also linked to the birth of the planetary system. That means they all evolved together. It is not that the sun was there and then planets came. That was the earlier theories I will show you next. So you can see the planets of our solar system, it will not to scale, of course, বুঝতেই পারছি যে প্রত্যেকটা স্পিন করছে একমাত্র ভেনাসটা একটু উল্টো ব্যাপার they're all spinning in the same sense and their axes are all approximately tilted at right angles to the orbital plane, which is this plane. Most planets rotate around the sun in the same direction and spin in the same sense. Their satellites also rotate around the same respective plane in a similar fashion. In most of the cases, the axis of spin are almost perpendicular to the plane of the ecliptic or the orbital plane. Sun also spins in the same sense. So this ultimately gave some hint to the birth of our solar system. And there are two persons, Titius and Bode. They also noticed something very strange for the 18th century astronomers. They found that our planets' locations could be you can be decided by a very simple arithmetical formula. That means the distance is number of the planet plus 1 in 3 plus 1 divided by 10 astronomical units. So therefore, you get, according to this law, this so many astronomical units for this. Now you can see this is for Mercury, for Venus. Earth is one astronomical unit, you know that. It is Mars, then asteroid, and then Jupiter, Venus. Now it is surprising to note that it is very correct. You can see that this simple arithmetical formula, if you plot, that is this curve, and actual positions of the planets, if you see, according these are the numbers, first planet, second planet, third planet, they also fall almost exactly on the same thing, which is described by this theory. Now, I must tell you that this tedious law of planets distances, প্রথমে যেমন এই অ্যাস্ট্রয়েডটা তো ছিল না, হ্যাঁ, তখন বলছে ওখানটা কিছু নেই কেন, পরে ডিসকভারি হলো যে ওখানে অ্যাস্ট্রয়েড গুলো আছে, বাট দ্যাট অলসো ফিটেড সো ওয়েল. Similar regular placement of satellites around planets have also been, যে অনেক যেমন জুপিটার or Saturn, their arrangement, spatial arrangement also follow a very similar law. Now কেন সেটা কিন্তু সারপ্রাইজিংলি আজ পর্যন্ত কোনো সায়েন্টিস্ট, there has been no physical explanation, scientific explanation behind this arrangement. এখনো অবধি হয়নি। এখন যদি কেউ করতে পারেন আপনারা, you will become quite. Now, because the solar system evolved from the gravitational contraction of a part of the galactic cloud, যেটা আমরা আসবো, the system acquired angular momentum. গ্যালাক্সিটা ঘুরছে, তো সেটা আমরা দেখালাম স্পাইরাল গ্যালাক্সি ঘুরছে, কাজে part of that also is rotating. And how these stars evolve? A part of the galactic cloud, they collapse under the self-gravity and they become ultimately a star and planet. So they will continue to have that angular momentum or rotational characteristics of the original galactic material. And that's why all the suns, their planet, everything also rotate. And they rotate in the same direction. Furthermore, the planets and the satellites all evolved from the thrown out material from the equatorial region. এখন আপনারা জানেন, যদি একটা জিনিসকে চাকাকে খুব জোরে ঘোরান, সাইকেলের চাকা, আর সেটা জলে ভেজা থাকে, then you know that the water spills away from that spinning wheel in a plane which is also confined to the plane of the wheel. So these planets, actually, since sun is spinning, so the equatorial region of the sun got spilled in the form of a disk, which condensed and gave rise to the planets. And therefore, it explains that why everything rotates in the same sense, in the same direction, in a very very regular feature. Thus, our next attention will be on the Sun Earth Moon system, the background against which the change of position of the planets and the Sun and the Moon are observed is formed by the fixed stars. Now, this whole solar system has a very well structured dynamical characteristics, and this is a major clue to its possible origin. After quick discussion, how you originated. We can estimate the relative motion between these two stars at a distance of 20 light years from Earth. এটা আমি বলেছিলাম না সূর্য থেকে করতে, let us do it. যে 20 light year দূরে একটা স্টার আছে। The proper motion of a star that is not due to the Earth's daily rotation and relative motion, যেটা আমরা দেখি সেটা নয়, is typically of the order of a few thousand of an arc second per year. Thus, it will take 1,000 years to notice a measurable displacement, and this helps the stars to form a reference background against which the motions of the sun, the planets, and the moon, etc., can be observed and quantified. You need always the graph paper. The positional astronomy studies these motions and the changing positions of the celestial objects within our solar system. Further, one has to also take note of the fact that our observations are from the Earth, which itself is moving around the sun. এইটাই হচ্ছে কি important ব্যাপার। আমাদের in the ancient time, whatever description of motion you find, they're all relative motion. They're not the actual motion and seen from the Earth. এটা ছোটবেলাতে পড়ে আমরা, আপনাদের হয়তো ওটা হবে না, আমরা ছোটবেলাতে নানা রকম থিওরি পড়েছিলাম, জিন্স থিওরি, জেমস জিন্স, etc. Now let us see what is the modern concept of origin of our solar system by the astronomy. Now it should be remembered that the formation of the solar system means not only the formation of the planets but also that of the sun. এই পুরো সিস্টেমটা ইভলভ করেছে through a same process. And there are mainly three theories which have been proposed so far. Historically, there have been two competing classes of hypotheses for origin of the solar system. একটা হচ্ছে dualistic or encounter hypothesis. তার মধ্যে একটা ছিল লাকলাক in 1745, আর একটা ছিল চেম্বারলিন and জেমস জিন্স in the early 20th century, যেটা আমাদের বলা হতো। আরেকটা হচ্ছে নেবুলার হাইপোথিসিস, যেটা কিন্তু ইমানুয়েল কান্ট, তার আগে ডেকার্টে এবং পরে লাপ্লাস তারা বলেছিলেন। নেবুলার হাইপোথিসিসটি এখন অ্যাকসেপ্টেড, উই উইল ডিসকাস দ্যাট। বাট বিফোর দ্যাট ওই যে ডুয়ালিস্টিক সিস্টেমটা কি ছিল সেটা একটু আপনাদের বলে দিই। ডুয়ালিস্টিক থিওরি হচ্ছে, এটা একটা হচ্ছে টাইডাল থিওরি, planets formed from the condensed gases ripped from an already formed sun. And একটা হচ্ছে কি ক্যাপচার থিওরি, during a close stellar encounter sun captures material out of which the planets form. দু রকমের ডুয়ালিস্টিক থিওরি, দুটোই এককালে প্রপোজ ছিল। সানের থেকে একটা মেটেরিয়াল ছিটকে গেল যখন একটা স্টার পাস করছিল এবং সেটাই পরে প্ল্যানেট হলো। আর একটা হচ্ছে গিয়ে যখন একটা স্টার পাস করছিল, সান ক্যাপচার সাম মেটেরিয়াল ফ্রম দ্যাট এন্ড দ্যাট বিকেম দি প্ল্যানেট। আর monistic theory হচ্ছে গিয়ে যে এটাই self evolved nebular theory which planets form at the same time as the sun in the same gas cloud. এটা হচ্ছে tidal theory, এটা হচ্ছে গিয়ে ক্যাপচার থিওরি, মানে tidal theory। এটা ভিজিটিং স্টার, এটা আমরা ছোটবেলায় আমাদের বিজ্ঞান বইগুলো থাকতো যে কি করে সোলার সিস্টেম ফর্ম হলো। এই স্টার, ভিজিটিং স্টার ইজ পাসিং বাই and its gravitational pull ক্রিয়েটেড পটলের মতো একটু শেপের একটা মেটেরিয়াল গ্যাস বেরিয়ে এলো সান থেকে, পরে সেটাই কনডেন্স করলো এবং সেটার থেকে ওটা দেখিয়েছিল যে প্রথম দিকের গ্রহগুলো ছোট ছোট সাইজ হবে, মাঝখানেরটা মোটা এবং সবচেয়ে বড় হবে, আবার ছোট হয়ে যাবে। অ্যান্ড এই যে এটা এদিকে যাচ্ছে, কাজে দিস অলসো উইল রোটেট, কাজে এগুলো সব একদিকে ঘুরবে। এটা ছিল ওই টাইডাল থিওরি। আর ক্যাপচার থিওরিটা ছিল এরকম, এমন অ্যাজ 1964 এটা উনি বলেছে, অবশ্য আগেও বলা হয়েছিল যে একটা ভিজিটিং স্টার যখন পাস করছে, সান ক্যাপচার সাম পার্ট অফ ইটস মেটেরিয়াল, এটা ওই পটলের মতো শেপের এরকম হয়, কাজে যে প্ল্যানেট গুলো হয়, এবং ইট উইল হ্যাভ ইটস মোশন, অ্যান্ড যেহেতু সানের মধ্যে আটকে গেল, ইট উইল স্টার্ট রোটেটিং লাইক দিস। এইগুলো হচ্ছে গিয়ে আগেকার থিওরি কিছু, এগুলো হুইচ ডু নট or which do not get accepted nowadays very much. So they have only historical. Modern advanced astronomical technology is continuously providing the evidence of the abundant existence of extrasolar planetary system. আগে ভাবা হতো আমাদের সোলার সিস্টেম ইজ ইউনিক, ব্রহ্মাণ্ডে আর কোথাও এরকম সিস্টেম নেই, কিন্তু এখন আমাদের অবজারভেশনাল পাওয়ার হ্যাজ বিকাম সো স্ট্রং that we can see many solar systems, and it has been now found that it is almost prevailing all over the universe. So the origin of the solar system cannot be due to a chance encounter which would have made the solar system unique, যেটা আগে ছিল, or very rare. This and the dynamical characteristics point toward the nebular hypothesis, originally Descartes proposed করেছিল, but supported by Immanuel Kant. Astronomy has advanced to such a level that we can actually observe the birth of our suns or some new suns in clouds of gas and dust. আমরা দেখতে পারি যেখানে সোলার সিস্টেম গুলো এখন ফর্ম হচ্ছে। এই যে এটা হচ্ছে বিরাট বিরাট সব গ্যালাক্সির মধ্যে গ্যাস ক্লাউড আছে, ডাস্ট গ্যাস, তার মধ্যে কিছু কিছু এরা কনডেন্স করে স্টার ফর্ম করছে। এগুলো হচ্ছে গিয়ে স্টার ফর্মেশনের জায়গা। এইসব এগুলো হিউজ, এই ডিস্টেন্স গুলো অকল্পনীয় ডিস্টেন্স, ফিঙ্গার গুলো। এই স্টার গুলো অবশ্য আমাদের আমাদের গ্যালাক্সি কাছের কাছে স্টার গুলো নয়, এইগুলো হচ্ছে গিয়ে যেগুলো উইথ দি স্টার্স আর বিং বর্ন। And interstellar cloud of gas and dust collapse under its own gravity, and predictions to nebular that is observed explains also that the features of our solar system, dynamical characteristics are explained, and observations continue to support this theory. যেমন এইগুলো হচ্ছে গিয়ে যেখানে সোলার সিস্টেম ফর্ম করছে অন্য জায়গাতে, অন্য একটা স্টার ফরমেশন হচ্ছে, তাহলে ওই যে মাঝখানে যে ইকুয়েটরিয়াল রিজিয়ন থেকে যে মেটেরিয়ালটাকে ছিটকে যাচ্ছে স্পিনের জন্য, সেইটাই দেখাচ্ছে এখানে। So these are young stellar disks in infrared Hubble Space Telescope. These are the pictures of the solar systems which are currently being born. So during it is the image of birth of solar systems, other solar systems. এখন এইগুলো দেখার পরে আর কোনো দ্বিমত নেই that nebular hypothesis এখন এইগুলো যেমন থাকে, these are the actual where this is the disk and here is the spinning central body which becomes the sun. এরকম হচ্ছে, first you have a piece of rotating cloud which collapses because of its own gravity. And why it is rotating? Because the whole galaxy is rotating. It is a part of the galaxy, so it will have that rotation. So when this cloud collapses under its self-gravity, এই রোটেশন আক্রান্ত তোমরা জানো এটা তো মোমেন্ট অফ ইনার্শিয়া কমে যাবে, যত সাইজ ছোট হবে, it will start spinning at higher and higher and higher speed. এবং এই পিরিয়ডটা অ্যাপ্রক্সিমেটলি 10 days to 6 years. তো একটা সেন্ট্রাল বাল্ব তৈরি হবে and তার থেকে কিছু মেটেরিয়াল বেরিয়ে যাবে সেন্ট্রিফিউগাল ফোর্সে, and it becomes a disk kind of thing. And it rotates faster and faster. And আরো 1 কোটি বছর পরে it will become very small, and যত ছোট হবে তত ভিতরের এনার্জিটা it will increase its temperature. So এখানে গিয়ে the temperature will reach a sufficient level where nuclear reaction can start. And once nuclear reaction starts, it will not, that pressure of radiation of nuclear reaction, that will prevent any further collapse. So it will be stabilized. And এই যে মেটেরিয়াল গুলো ছিল এগুলো আস্তে আস্তে কনডেন্স করতে শুরু করবে and they become the planets. And this event is considered now the sun has entered its main sequence. Main sequence কেন? Because this is this form in which sun continues to live for billions of years. এগুলো তো খুব শর্ট, ইন টোটালটা তো 1 কোটি বছরের মধ্যে হয়ে গেল। কিন্তু এরপরে যেটা মেন সিকোয়েন্স হলো যখন, our current sun, for example, it is already 4.6 billion years. So this is the main period of a solar sun, its life, and gradually this dust, etc., which got accumulated during this, because of solar radiation, strong nuclear reaction, all this dust gets removed, just shift, and the system becomes clean system like this. So this is the way a solar system is being born, and that is the currently accepted thing. And we are now seeing various distant objects which are approximately in this region that the suns are just being born. So I think I will stop here.